Have you ever walked out of an exam thinking, I knew this? I understood every concept. So why didn't I score higher? Maybe your teachers told you that you overthink everything. Maybe your friends memorize facts quickly while you keep asking, what is the mechanics behind this? If that sounds familiar, you may not have a weak memory. You may simply have a different way of learning. And if your quiz result was IT, based on Carl Jung personality types, you belong to what we call the Analytical Sage with Introverted Thinking. And this video may completely change how you study forever. If you haven't taken the quiz yet, don't worry. If this description sounds like you or someone you know, keep watching. Then take the personality quiz afterward using the link in the pinned comment or description to discover more accurately about your personality type and find the study strategies that suit you best. As an analytical sage, your mind naturally looks for logic before acceptance. Instead of asking, what should I memorize? Your brain automatically asks, why is this true? How does this actually work? Can I prove it? That is your greatest strength. Your secret power. You can break down highly complex coding, math, or engineering problems into perfect, flawless logic. Your worst study trap. Sinking into deep overthinking and trying to understand why a rule exists instead of just memorizing it to pass the test. Before we continue, here's something important. No personality system can perfectly describe every person. Think of this profile as a practical guide, not a label. If most of what you hear feels familiar, the study methods in this video are likely to work especially well for you. Your goal isn't to fit inside a personality box. Your goal is to understand how your own mind learns best, because once you understand that, studying becomes dramatically easier. Here's why many IT students struggle in traditional classrooms. From an early age, most education systems reward one thing: remembering information. Teachers often say, don't worry about why, just learn it for the exam. For many students, that's enough. But for analytical sages, it feels almost impossible. Your brain resists memorizing ideas that don't make logical sense. That doesn't mean you're stubborn. It doesn't mean you're slow. And it certainly doesn't mean you're less intelligent. It simply means your brain prefers understanding over repetition. Imagine someone hands you a machine you've never seen before. Most people are happy learning which buttons to press. You want to open the machine, take every part apart, understand exactly how each gear works, and only then will you trust using it. That's exactly how your mind approaches learning. The problem? School often mistakes deep thinking for slow learning. While others are already memorizing formulas, you're still trying to understand where those formulas came from. It can make you feel like you're falling behind. But something interesting happens later. Once your understanding becomes solid, your recall becomes remarkably reliable. Because you aren't remembering isolated facts, you're remembering an entire logical system. Think of your mind like building a skyscraper. Most students build from the top down. They memorize the roof first. You build from the foundation upward. It takes longer in the beginning, but once the foundation is complete, the rest of the building rises much faster. The key is learning how to use your brain instead of fighting against it. Your greatest academic weapon is something called first principles thinking. This approach has been used by many great thinkers and innovators because it focuses on understanding the basic truths behind a problem before jumping to conclusions. Most students study like this: formula, memorize, repeat. Your brain doesn't enjoy that process. Instead, start with the simplest questions possible. Imagine you're learning Newton's second law. Instead of immediately memorizing force equals mass times acceleration, pause. Ask yourself, why does a heavier object need more force? What actually changes when something accelerates? What problem were scientists trying to solve? As you answer those questions, the formula slowly stops becoming a random collection of symbols. It becomes the natural conclusion of a logical story. The same approach works in mathematics. Don't just memorize integration formulas. Understand where they come from. In biology, don't memorize the steps of a process immediately. Ask why each step exists. In economics, don't memorize graphs first. Understand the human decisions behind them. Here's a practical study routine. Whenever you begin a new chapter, spend the first 10 minutes asking only, why? Why does this happen? Why is this formula needed? Why couldn't it work another way? Write those questions down, then answer them as you study. You might feel slower during the first hour, but by the end of the chapter, you'll often spend far less time memorizing than everyone else. Because understanding creates stronger memory than repetition alone. When ideas connect logically, your brain has many different pathways to retrieve them during an exam. That's why analytical sages often remember concepts years later. They didn't memorize them. They understood them. Now, let's change how you take notes. Many students believe beautiful notes automatically lead to better grades. For many IT personalities, that's simply not true. Your brain often performs best when information is organized like a logical system. Instead of decorating your notebook, design it. Think like a software engineer. Every idea should answer one simple question. If this happens, what happens next? Build decision trees. Use arrows. Create flowcharts. Break large chapters into smaller logical blocks. Instead of writing 10 pages, ask yourself, could I explain this chapter on one page? For example, instead of writing 3 pages explaining chemical equilibrium, draw one simple flowchart showing cause, effect, exception, formula, application. Your brain loves seeing relationships. That's far more useful than rereading paragraphs. One important reminder though, don't chase perfection. Some IT students spend 3 hours creating the perfect flowchart and only 30 minutes actually studying it. Remember, your notes are tools. They are not the final product. The goal is understanding, not creating artwork. Here's where many brilliant students accidentally waste hundreds of study hours. They reread, highlight, read again, highlight again. It feels productive, but your brain isn't actually being tested. Instead, close the notebook. Take a blank sheet of paper. Now rebuild the entire chapter from memory. Redraw your flowchart. Rewrite the formula. List the key ideas. Whatever you cannot remember, those are the areas that deserve your attention. This is called active recall, and it is one of the most effective ways to strengthen long-term memory. But we're going one step further. Once you've rebuilt the chapter, it's time for the Feynman technique. Imagine you're explaining the topic to a friend who missed every lecture this semester. No technical jargon, no complicated textbook language. Just simple, everyday words. If you can explain photosynthesis, probability, thermodynamics, or constitutional law so that a 12-year-old could understand the basic idea, you truly understand it. If you can't, that's not failure. It's feedback. Go back, find the missing link, then explain it again. Because true understanding isn't measured by how complicated your explanation sounds. It's measured by how simple you can make it. That's when you'll notice something remarkable. Exams stop feeling like memory tests. They become logic puzzles. And that's exactly the kind of challenge your mind was built to solve. Here's something many analytical sages never realize. Understanding a concept and scoring marks are not always the same thing. This may be one of the biggest reasons intelligent students underperform in exams. Imagine you're asked a simple 2-mark question. Instead of writing exactly what the examiner expects, your mind immediately begins exploring deeper possibilities. But what about this exception? What if this assumption changes? Should I explain the history behind it? Before you know it, you've written half a page. The problem isn't your intelligence. It's that your mind is solving a much bigger problem than the examiner actually asked. Remember this, your examiner isn't grading how deeply you can think. They're grading whether you answered the question that was asked. So here's your new strategy. Before writing any answer, pause for 3 seconds and ask yourself, what exactly is this question asking? Not, What do I know about this topic? Then, write the key points first. Underline important keywords. Use diagrams whenever appropriate. And once you've earned the available marks, move on. Save your brilliance for questions that actually require deeper thinking. In exams, clarity almost always beats complexity. Let's talk about something every student experiences: exam stress. Analytical sages often believe that anxiety means they haven't prepared enough. So what do? They keep studying. One more chapter, one more formula, one more revision, one more YouTube video, one more hour. The problem is, after a certain point, you're no longer improving your preparation. You're simply feeding your anxiety. Here's something important to remember. Your brain naturally searches for certainty. But no exam ever feels 100% certain. If you keep waiting until you feel completely ready, you'll never stop studying. So instead of chasing certainty, build trust. Trust your preparation. Trust your revision system. Trust your process. The evening before an exam, don't begin an entirely new chapter. Instead, review your flowcharts. Review your summary sheets. Teach one topic out loud. Then stop. Get proper sleep. A well-rested analytical brain solves problems far more efficiently than an exhausted one. Remember, your goal is not to know everything. Your goal is to recall what you already know when it matters most. Every personality has a hidden weakness. For the analytical sage, it's overthinking. Imagine this. The exam begins. The first question looks easy, almost too easy. Your brain immediately whispers, "There must be something more to this." Instead of writing the obvious answer, you begin exploring every possible interpretation. 5 minutes become 10. 10 become 15. Meanwhile, the clock keeps moving. Here's another trap. Many IT students delay solving practice questions because they believe they must first understand the chapter perfectly. But practice questions are not the reward after learning. They are part of learning itself. You don't become a better swimmer by reading books about swimming. You improve by getting into the water. The same is true here. Attempt problems earlier. Make mistakes earlier. Learn earlier. And when you're writing mock exams, follow one simple rule. Good enough beats perfect. If the marking scheme awards 3 points, write the best 3 points. Secure the marks. Move forward. Don't try to solve the mysteries of the universe inside an examination hall. When analytical sages discover environments that reward deep thinking, they often thrive. You'll frequently find people with these strengths in fields such as engineering, computer science, artificial intelligence, data science, physics, mathematics, economics, research, medicine, finance, law, architecture, and systems design. These careers reward people who enjoy understanding how complicated systems work. But here's something even more important. Your greatest strength isn't your intelligence, it's your curiosity. While others may stop once they find an answer, you keep asking better questions, and better questions often lead to better solutions. Never lose that curiosity. Just learn when to slow it down and when to let it fly. If you've spent years believing you weren't smart enough because you couldn't memorize as quickly as everyone else, I hope this video changed that belief. You don't need to think exactly like everyone else. You need to understand how you think. The education system often rewards speed, but life rewards understanding. Some of the world's greatest discoveries, greatest inventions, and greatest breakthroughs came from people who refused to accept easy answers. They kept asking, why? If this profile describes you well, don't fight your natural way of thinking. Refine it. Strengthen it. Use it wisely. Because your goal isn't to become someone else's version of a successful student. Your goal is to become the strongest version of yourself. So, how accurate was your result? Did this sound like the way your mind really works? Tell me in the comments. I'd genuinely love to know. And if you're an IT personality, share one study habit that's helped you succeed. You might help another student who's struggling with the same challenges. Remember, finding your personality type is only the beginning. Every personality learns differently. And in the next videos, we'll explore the unique strengths, study methods, and hidden traps of the other brain types. Who knows? You might finally understand why your friends study completely differently from you. Click the next video on your screen to continue discovering the other Jungian personality types. Until then, keep asking better questions, keep thinking deeply, and never stop learning. I'll see you in the next video.